Awesome, we're live. Hi everyone, I'm Amelia from Seneca. This is Colleen. We're going to get started in just a few minutes. But while we're waiting, if you'd like to introduce yourself in the chat, that would be super. We'd love to know kind of what school everyone's from, whether you've heard of Seneca before, things like that, and get a bit of conversation flowing. That would be super. Just for anyone who's just joined, welcome. Just waiting a few moments to let people trickle in before we get started. But if you could say hello in the chat, that'd be super helpful. Also lets me know that you can hear me as well, so that's always reassuring. Oh, super. Looks like we can be heard, which is awesome. So from S. Hudson's secondary maths teacher and primary math outreach, lovely to have you here. Got Dennis as well. And hi everyone. Super. That's good news. We can be heard, Colleen. That's a great start.
Thank you for coming.
Fab. So as everyone starts to trickle in, I'll kind of get the whole evening started. Firstly, thank you so much everyone for joining, particularly on a gloomy November Tuesday afternoon. Really appreciate it. We're really excited to have Colleen here, really excited to be part of Maths Week England as well. Just to give you kind of an idea of how this evening is going to work, I'm going to start off by just explaining a little bit about Seneca, in particular our new kind of maths tools on Seneca, which we're very excited about. And then what I'm going to do is hand over to Colleen, who's going to give her amazing presentation, which I'm sure you'll all have lots of questions about. So I'd really encourage you to, whenever questions come up, just pop them in the chat. And then we're going to have a full Q&A session afterwards. And I'm going to keep monitoring the chat throughout so that we can make sure that all your questions get answered. So in that case, without further ado, I will quickly chat a little bit about Seneca before I hand over to the main event with Colleen. So basically, for those of you who haven't heard of Seneca before, Seneca is an online learning platform which is all based on using cognitive science and things that we know about how the brain works to help students learn more efficiently and more quickly. So what we've recently done with our maths courses on Seneca is really just kind of reinvent them a little bit to make sure that we are providing students with enough practice to really make sure that they are really embedding the principles and the ideas that they need to know in order to answer the questions. So obviously, as you can see, it starts with a little video. All of our courses now, it explains the main concepts. And then what happens is students dive into our kind of calculation modules. Now, the way that these are generated means that there is an infinite number of possibilities for the kind of questions that could come up. So every single time a student does this course, they're going to see a multitude of different questions. They're never going to see the same question twice. So that's really good for making sure basically there's as many practice questions as they need for each topic. Now, as you can see, the way that it works is the question will come up and then I'll be able to type in the question as a student. So going to be testing my math skills now. Hopefully I don't embarrass myself. That would be not ideal way to start a maths webinar with it. But as you can see, I can kind of type in all my working. I've got ample lines to do that. So I can type it all in here. And then I put in my answer and press submit. And then as you can see, I get kind of automatic feedback. I can also see the whole mark scheme and all of the lines of working there. So I can work out, you know, if I did get it wrong, exactly where I got it wrong. And then I can move on to the next question. So these kind of keep coming up. Now, because Seneca is adaptive, basically every time that a student goes through, the difficulty level of the questions will adjust to how they're doing. So here, let's go 1x equals. So if I'm doing really well, then I'll start to see kind of slightly harder questions. If I'm doing not so well, I'll kind of stay on some of the simpler questions. So here you can see I've gone up to the kind of pro level, which is exciting. Sometimes I don't reach that. Maths is not my strong suit. But here you can see as well that if students get stuck, which sometimes they might do, particularly if they go up a kind of difficulty level, is they can get a hint, which is really helpful for kind of walking them through the steps that will be required to kind of answer the question and really like develop their working out skills. So here I can put in -2, and then I can see if I got it wrong, exactly why I didn't get it wrong, and then pop in the answer there. Again, got that one wrong there as well, and then get down to my answer here. And so I got sort of 2 out of 4 on that one. And then again, because I got that one wrong, it's going to adjust to my ability level. If need be, it will drop me down a level if I'm struggling. And another of my favorite features is just on calculator questions as well. We've now got a dynamic calculator. So hopefully it makes it easier so students aren't flipping between their calculator and Seneca. If I type in, say, -12 plus 20, you can see here that it does the automatic calculation there for me. And all I have to do is press enter to kind of accept that. So the calculations happen inside Seneca as well. Obviously only on calculator questions. On non-calculator questions, that's disabled. But we're really excited about this. If you've got as well like colleagues in the science department, even geography, business, any kind of subjects with calculation elements, this same model of really kind of doing the practice and reinforcing how to answer lots of different varieties of the same question style is always available for them. So the other best thing about it as well, that I forgot to mention, is completely free to use Seneca as well for students and for teachers. As a teacher, you can sign up, set assignments, and see exactly how well your students have done on them as well. So we're basically very excited about it. But that kind of ends my spiel on how Seneca is working. So without further ado, I'm going to hand over to Colleen for the main event.
Thank you. Right, so here we are. Now, I'll just briefly introduce myself. Thank you all again. Thank you very much for coming after probably a busy day at school. So in case you haven't come across me before, I'm Colleen Young. I've been teaching forever. I started teaching in 1980 when all the world was linear, and I have lost count of the number of spec changes since then. We've had coursework, no coursework, we've had modular, we've had linear, modular again, back to linear. So when I started teaching, I was teaching linear A-level. My own students are from year 7 to A-level further maths. I deal a great deal with distance learners these days. Now, please do use the chat, as Amelia says. Do put any questions at all that you have, do put them in. Or if you think of something later, please, you can contact me via Twitter. You can see I'm at Colleen Young on Twitter there, or by my blog, colleenyoung.org. I'm going to be mentioning quite a lot of resources this afternoon. But all of the resources, the links are, you can find them all on my blog. On colleenyoung.org, you'll see, if you don't know it, there's a menu on the right-hand side, and I have just made sure that the Rosenshine page is there. Now, in fact, on the blog, there's even more slides than I've got now. I mean, there's lots of them. You can just take what you want. But I've adapted sort of that presentation to sort of extract the things that I really wanted to talk about this afternoon. Okay, so I just want to mention, are you familiar with this paper? Rosenshine's Principles of Instruction paper, this one that you're looking at here, I think it's so accessible. It's really well structured. It presents Barrett Rosenshine's 10 sort of principles of instruction, which are based on evidence. In fact, it's a cognitive science really that Amelia's been talking about. So highly recommended in case you haven't read it. It's so accessible. I like the way it's structured. It takes each of the 10 principles and discusses the evidence for them, and also, very importantly, what it means for a classroom teacher. I know you'll have probably seen Tom Sherrington talk about this a great deal. Now, I do like this list of 17 principles of effective instruction. Now you're thinking, hang on, I thought there's 10. I mean, there are, but Baruch Rosenstein actually lists the 17 that the 10 have come from in his paper. And I think they're actually rather useful. You may well have seen Tom Sherrington actually put these into groups. I was actually doing that myself before he did. Maybe I should have published something, but I do think, as I say, they're useful because they provide a lot of detail. And I've also referenced on the slides the Great Teaching Toolkit, the evidence review. I've put everything that if you want to read it, you can. I've put it on the page of my blog. But I think this is a good read. And what this is talking about, this paper, is what really makes a difference. And I think most of what we're talking about today comes from their section 4, activating hard thinking. We've got to give students an appropriate sequence of learning goals. We've got to interact with them. We've got to explain clearly, and so on. I just include it for reference because it's a good read. And in fact, it uses many papers, including Rosenstein's, so there's an awful lot of similarities. Now, I have grouped the 17 statements that you saw there into 4 areas: instruction, questioning, review, and practice. And we're looking a bit more detail at each of those. Okay, so starting with instruction. Now, on the right-hand side there, I've just reminded the statements that I've put in here. So, yeah, how do we... I mean, it's... The good thing about all this is it seems like common sense, doesn't it? But I think these are good material to use to actually think about our teaching. What are the small steps? Yeah, and are we giving students too much information at once? And how clear are instructions? Are we thinking aloud and modelling steps? We've had so much more practice than our students have, haven't they? Are we providing many examples? Now, in fact, we've just seen a nice example there. On Seneca, you can provide as many examples as you want, and ideal, in fact, that it adapts if the students are getting them, plenty right and taking them to professional level. So ideal. So now then, let's actually have a look at some resources. Are people familiar with the very brilliant Andy Lutwich on TES? I do say in the chat if you sort of use any of these. But I think these are excellent. And he's got a whole series of what he calls building blocks. So I'm thinking about the new material in small steps. So I think resources like this can just help us think about the small steps. I found these actually make great revision in year 11, as well as just for me to look at thinking about a teaching sequence. But you can see the way they work, starting with the basics at the bottom and gradually building up right all the way through to composite functions for the GCSE students. Very nice. And the good man, he always provides the answers. So that is just so useful. I know we could work them out, but isn't it useful when it's all provided? Yeah. Yes, I see Lindsay using. Yeah, he's got so many, and he's one of these powerhouses who just keeps churning out things, but they are very well thought through. So highly recommended. hello to everybody. Right. So, and look, there's another one, inequalities. So again, you see the same structure. I think I've used all of these, but we've got that structure with, the real basics at the bottom, but right and through number lines, and then through to the harder GCSE questions. So I think this sort of thing really helps you think, if you're teaching inequalities, just of a sequence, to to think of those small steps. And as I said, all the answers are there, so absolutely brilliant. Do people use white rose at all? I know it's used in a lot of schools, but even if you don't actually sort of use it as a scheme of work, I do like their small steps document. So I'm still thinking about breaking things down. What are the small steps in any topic? And there's this PDF with years 7 through to 11, and it's searchable. So if you search on equations or whatever, you'll see it wherever it occurs. So again, just very useful for thinking about those small steps. And of course, White Rose they've got all the resources, lots of free resources to actually go with this. You can look at exemplar questions. So yeah, absolutely brilliant. I'm a real White Rose fan. I think it's very clear. So there we are. There's more, but just reminding you how useful it is for small steps. And even if you don't use White Rose, as I said, it's useful. So just a reminder, we're looking at sort of the principles, Rosenshine's principles, instruction, providing many examples and so on. So let us have a look at some more resources to help us actually do that. Now, are you all using the very brilliant maths whiteboard? Matt Woodfine, he just keeps churning these out. But these are so useful, aren't they? Now, I use this sort of thing. I use it in class, but I also use it. I do an awful lot of webinars for my distance learning students. And this sort of thing is ideal because we can model examples, can't we? I can do an example and then they can try an example. And sort of I do, you do approach, which, helps reduce the cognitive load for the students, doesn't it? But they can have a go. With my distance learners, the various online systems I use, they've all got whiteboard tools. So I can easily sort of display a multiple choice question and then put a poll up and they can actually enter their answer. So I can see who said what, but the students don't see that. They just see a summary, and that's very useful. There's also things like Whiteboard that I can turn on sort of pens for them all to use. So I find that very, very useful. And something like this site, Math Whiteboard, is ideal. So I think a lot of people are using it now. You'll be familiar with it. The dots at the top, you can choose your difficulty level. And if you go through, you'll see, yes, it gets more and more difficult. And again, it's randomized. So you can have all the examples you want, all the student practice you could possibly want. Going to the hardest, at GCSE we get this, don't we? GCSE higher, an identity, find A and B. So here's what I do. Can you see all that there? So notice what I'm up to here with my use of colour. So you'll see I've got the coefficients of x in red and I've got my constant terms in blue, and I've used that throughout. It's something I do a great deal, and in fact use of colour in mathematics is a whole other presentation from me. But I do find, and remember Rosenshine, great teaching toolkit, talk about clarity of explanations. And I find the right use of colour can really, really help with that. Also, for clear explanations in our instruction, then diagrams. Now, there's plenty of resources around like this, aren't there? This is from Purposeful Maths, this one. But this is ideal. I like the way the first example is done completely. And then there's, you gradually drop the scaffolding, or you've got a complete mix. And again, I find quite short exercises like this ideal for my online learners. They could scribble on the board, or what they do a lot as well is use the chat. So we can have, we can have some good discussions. And I always try to make learning. I'm sure you all do. Just very, very active. Ask lots of questions, as Rosenshine would say. Now, I don't know whether anybody's ever seen this. Sometimes it surprised me what students like. You know, you've got all these sites like bells and whistles. David Smith's The Maths Teacher has been around. Oh, I think it's been around for decades, all free. And I do like, it amuses me. And he says, no subscriptions, no registrations, no logins. You can just go there and use it. And he's got videos and he's got like worked examples. And look, there they are. They're just handwritten, but they're all very neat. And I've been surprised sometimes how much students actually like these. This is a really nice little trigonometry exercise because he's very craftily used examples to find every unknown side and every unknown angle that you could possibly think of, and using, you know, all of sine, cos, and tan. And not only are there the questions, there's teaching videos, there's transcripts, and there's worked solutions. So just another source of very useful examples, worked examples. Does anybody use CIMT? Because here's another great source of questions. This is from their interactive materials. Now, CIMT is another. It has to get a mention because I think it's been with me for so much of my teaching career. If I'm ever stuck for an example, I mean, you can normally find what you want these days, can't you? But I know I can always go to CIMT and I'll find them. But they're interactive materials for years 7, 8, and 9 are really rather nice. And I think there's a lot of elements of sort of Rosenshine here, aren't there? Because there's lots of questions, there's practice, it's guided practice. Because look, we've got the worked examples to look at, and then the students can try, and then they get feedback as well, so they can check as they work, and really nice, you know, very nice, clear examples, I think. So I'm a CIMT fan. There's lots of interactive materials. You have to watch out. Some of them use Flash, which is no good these days, but most of the interactive materials are absolutely fine. But I thought worth a mention because they are nice for self-study. I sometimes use these in class, and then students have done a bit more for homework. I do like using things in the classroom, actually in the physical classroom, or in one of my online sessions. I like showing them things they can then use themselves, because even students, if you know, you most likely teach students in a classroom every day, but they're only in the classroom for a limited time, aren't they? They're actually outside the classroom a lot. So I find there's an awful lot of similarity between, you know, my online learners and you know, learners actually in the classroom. I'm sure you know Johnson Hall's wonderful MathSpot, of course, also his non-examples. So explaining concepts, non-examples are very, very useful indeed. And it'll just really help them think things through. I like the different formats available on nonexamples.com. I find Odd One Out and the multiple choice quizzes are absolutely ideal for getting feedback from the students, because again, I could set polls to for the students to actually put their answers in. We can discuss them. And with the examples and non-examples, I like to get students to make up some more. So we might look at examples and non-examples and say, right, give me some more. And they can either use the chat or online whiteboard tools or whatever is appropriate. So there we are. Look, there's just an example, you know, which is not a parallelogram, and why. You can have some really nice discussions with these. I think thinking about non-examples does actually help them understand more about the properties of whatever it is that you're discussing. Freya models. Do any of you use Freya models? There's Pete Matlock's site is lovely for these. It's another very good source of examples and non-examples. If you don't know it, do have a look, but I highly recommend that. Talking about vocabulary is very important, isn't it, for our students to understand, all the different terms. Right. So moving on now. I don't know, this I think is less well known. I've gone from Maths Whiteboard. I'm now on a completely different site. This is Maths Whiteboard. Has anybody seen it before? I'm on my my colour theme here. Math Whiteboard. Students can actually use this in that you can just, if you Google Math Whiteboard, you'll find that you can just start a board without logins or anything. What I'm demonstrating here. Oh, I'm just going to come back to that question there. I've done both, Angel. That's a really good discussion point. And I think it's very nice to actually, or maybe partly filled in, and get them to provide, or maybe one example, one non-example, and get them to fill in more. So yes, I think there's a case for both, but filling them in as a class exercise is a really nice thing to do. Okay, so back at my Math Whiteboard. Has anybody seen it before, by the way? I love their colour equivalence feature. So you can see as you look at the slide on the left there, I'm using it for checking order of operations. So there we are, 7 minus 2 times 3. It uses the dot for multiplication on here. 7 minus 6. 7 minus 6 is yellow because it's the same. And 1 is yellow because it's the same. And look, there we are. I've got another example, 5 times 3. Yes, that's 15. But look at the equation on the right. I want to solve 3x plus 1 equals 13. So I'm going to start rearranging it. 3x equals 13 minus 1. Yes, it's still yellow. It's still equivalent. So you can check as you go. Very nice. You can see what's happened. 3x equals 12. X equals 4. Yes, it's all yellow. But look at the right-hand side. 3x plus 1 equals 13. Then we've got an algebraic slip. 3x equals 13 plus 1. That's not equivalent. So the colour's changed. So I think very, very nice for actually checking work. It's pretty sophisticated. I recommend a play. It is free to use. If you've got a tablet or a pen or anything, you can actually handwrite, and it will turn it into math type. Melina, you've used it. Yeah, it's great, and it's going from strength to strength. I was actually talking to Don the other day about this, and they've got all sorts of new features. So I'm a fan, definitely. It's well worth keeping an eye on. So I do love having all these tools, not for the sake of it, but it's great for teaching, isn't it? And the students are learning, and they can use it themselves. So, there was me using Math Whiteboard for a Don Stewart activity. The nice thing is you can very easily upload an image. You can also upload a PDF and write on it. So it's very nicely full featured. It's a really good resource. There we are. Oh, and there's more. You can also, if you drag an expression to the graphing area, there we go. Up comes a graph and a table if you want it. Multiple representations. So important, isn't it, for helping our students understand and thinking about our explanations. I personally link algebra and a graphical representation wherever I possibly can, and encourage students to actually do the same. Something like Desmos is so easy for students to use, isn't it? And GeoGebra. Do you use GeoGebra at all? The great thing I think about GeoGebra, because you don't want to. Oh, hello, somebody else. Hello. With GeoGebra, you may not want to write your own. But the thing is, with GeoGebra, there is so much out there. If you just Google, GeoGebra rotations or something, up will come all sorts of GeoGebra apps all ready to go. And you've got everything from primary through to further maths with GeoGebra. So there we are. Look, we're moving Bunny around for the younger students, and Bunny's going to demonstrate 3 add -10. So sort of Bunny, like, if there's a slider, so off Bunny goes to 3, and then Bunny turns around, goes back to -10, and we'll see where we end up. But it's really nice. So I'm thinking about, you can see my statements there, giving clear and detailed instructions and explanations. Another lovely site, again with great things to explain to students, and I've used things from Math is Fun. I've used resources from year 7 again through to further maths. They've got some really nice matrices and eigenvalues and eigenvectors on Math is Fun, and it's another one of those sites that has been there a long time. So very useful. But look at all you can do with that. Snap shapes of the grid, but you can display angles, the sides. So it's a lovely way for students to experiment with perimeter and area. Yeah, yes, GeoGebra. Going back to, there's another nice one, the NCTM illuminations. I'm looking for nice visualizations to help in our explanations. Students have got to find the factors of 24, and you can see them there. 1 by 24, 2 by 12, 3 by 8, 4 by 6. There's really nice, clear instructions. And the good thing about these, because you can't just throw things at students, can you, and let them get on with it? There's suggested questions. There's explorations for the students to actually try. They're nice and simple to use with full instructions. And look, what happens? The students can drag rectangles. If the area is 12, then that rectangle will stay and it will get listed in the factorizations at the side. And then they can just experiment. So I'm just looking at lovely visual ways to explain things to students. Here's another NCTM illumination. Now look at this, it's absolutely lovely. You can rotate that model around. You can choose a solid or net. So look, there we are. I've chosen the net. You can also, and so students can explore faces, edges, vertices, and again, those questions they can try. So you can set this sort of for homework. You could also colour everything in. So look, see what I've done. So I've coloured the net, and then you can fold it all up again, and you can see your cube, and you can rotate your cube, and you can look at the cube and the net together. I mean, you can't do that on paper, can you? So that's a very, very nice demonstration. Have you seen, we talk about the GeoGebra and how everything's out there already. Have you seen Edexcel's lists mapped to GCSE for all these lovely GeoGebra apps that they've written? That's really very, very useful indeed. Edexcel have got GeoGebra lists for GCSE. They've got GeoGebra for A-level maths, and I think there's further maths as well. So as I say, you don't have to write your own, because I think busy teachers just want something out there that it's already good. There's so many good GeoGebra authors. You sort of don't have to write our own, but that's a very useful set of resources. Although it's linked, they're linked to the textbooks. They do stand alone. As you can see, my example there of the factor pairs visualized. I popped in some circle theorems as well there, look, because I think circle theorems I would not do without GeoGebra. Right. Or transformations, absolutely superb, I think, for GeoGebra is brilliant for showing transformations. I really like that. You can, lots of what if questions. And here's a lovely one on rotation. And again, you can show the original, you can show image, show the center. It's just really clear for children to experiment with. With my distance learners, I demonstrate these a lot. Or you can send them the applet to actually have a play with themselves. You sort of goes beyond just looking at sort of paper examples. So I think that is ever so useful. Does anybody use the PhET simulations? Again, fantastic for explaining things. There are questions, there are teachers' resources, but they are so nice. This is one of my favorites. I use it a lot. GeoGebra, yes, I think I would be I'd just be choosing the resources very, very carefully. I might want something simpler for foundation students, and something a bit more complex for the higher. So yes, I think obviously with the foundation you want to challenge them as well, don't you? Because there's quite a lot of crossover material. So yes, I think we judge, don't we, the students in front of us. It's a physics favourite and a maths favourite, and I think it's science generally. So this one I like a lot. You can show partial. There's lots of choices. You can, and the nice thing is you can set up your own expressions. So I put in x plus 3 times x plus 2 there, and you can choose to see exactly what you want. And this is ideal for students to check their own work at home as well, isn't it? Because you could, sort of set them some homework, but also show them how to use this, and they can actually check their answers. So I'd say, highly recommended. There's so yeah, find the site. So this is nice. Look, go backwards. That's another whole session from me, but good mathematicians can go backwards. So we've got to find the side lengths this time. Very nice indeed. Because thinking about things backwards, I think, really helps them think things through forwards, and really helps them sort of maybe ask deeper questions when you've got to go backwards. And I've got to mention Trig Tour, especially for your A-level students. The PhET simulation for Trig Tour is a beautifully easy one to use. So absolutely worth a mention. And I think students can learn a great deal looking at this. Again, ideal for self-study. I don't know whether anybody recognises this. Some of the examples in the old, and they're still available, if you know where to look. I think I've linked to them all, but the old exemplification examples, the old national curriculum ones. But there's some lovely examples on geoboards. And geoboards, something I find, there's lots of online free ones. Enrich do some. And students can actually use an online geoboard very, very simply to look at tasks like this. We're looking at properties of triangles, and look, what they got to do there is find the 8 distinct triangles that you can construct. And doing that on a geoboard is a lovely way to do it. And then think about their various properties. That task then extends to how many on a 4x4 geoboard, which keeps them busy for a while. I think it's 29. It's really nice task. So thinking about questions now, I mean, in a way there's such a lot of overlap, isn't there, between these areas, but ask a large number of questions, get the students to explain. I mean, there's nothing like explaining to somebody else, is there? And this is something I try very much to do. I'm sure you do in class, and get them to explain it, because I think the more they can speak clearly verbally, that helps them to write more clearly. Because sometimes students, we're probably good at discerning what they mean, aren't they? I think encouraging them to talk and explain just what they're learning is such an important thing to do. And we want to provide feedback and corrections, don't we? I'm going to skip through those. This is me talking to some GCSE students recently. It was an online class, this one, and I was asking which of these are identities and why are they identities. Now, what we did, I had a group. I think there was about 10 of them actually in this particular session, but And I turned on the multi-user whiteboard tools, and 2 of them started attacking straight away. I took a shot there, and they were also using the chat. But again, so it's a really easy way to get responses actually from the students, but carefully chosen questions, as you'll see. Because it was A there that they identified last, but what an important one. So that's what I was up to there. I want to mention the standards unit because it's just such a such a classic, isn't it? Do any of you use the standards unit? It's an oldie but a goodie. I think there's such amazing resources in the standards unit, and because the teachers' notes are provided for every activity, they're such good questions. And you can see that's an extract you're looking at there from Malcolm Swan's What a Legend, his wonderful Improving Learning in Mathematics, the book that goes with it, all free, all accessible. My favourite source of standards unit materials is actually University of Nottingham. You don't need any. I know STEM have got it, but you don't need any logins for this. You just go straight to the site and it's all there. The software no longer works, but there's now alternatives to software. So if anybody's looking for those old building houses, wonderful building houses resources, which are fantastic for plans and elevations, you can actually still find those. And I can let you know where they are if you want to do that. So another source of very nice sort of questions you will find from MEI. MEI have tasks for GCSE and also A-level, and they do these tasks for GeoGebra, Desmos, Autograph, and calculators as well. And the nice thing about them, here we are. So look, here's a GCSE task. Now they do actually give instructions for, actually this is some Desmos instructions. Hang on, is it Desmos? Anyway, they give you instructions for whichever tool you want. Now students could set them up themselves, or what you could do, of course, yes, please, to building houses. I'll make sure it's on my blog. So yes, what I will often do is actually create the page myself and then just give students a link to it. A-level students might like to actually try creating some other things because they should be using technology, shouldn't they? But the great thing about the MEI tasks is they provide questions for discussion. And there's further enriching tasks as well. So I'm just talking about good questioning, and it is so useful to have sources of good questions, which the ones I've looked at, I found they are, very thoughtful questions indeed. So highly recommended. Transom has to get a mention. Thinking about students getting feedback and being able to check their work, Transom has got huge library of resources. Great for student self-study, I think, because there's that maths map that students can use. So, and this is another website, one of my enduring websites, I think. It's been around for a long time, and John Tranter just keeps on adding to it. Do get his newsletter. If you don't get that, it's definitely worth it. So, of course, the ultimate for questioning has to be, doesn't it, diagnostic questions. So do you all use this? I expect most classrooms do. What I do like about diagnostic questions is the insights you can get. It's fantastic. So if you set a quiz to a group of students and they actually fill in the answers online, then you know ahead of time how you can feedback, because you can see the order of difficulty for the question. And that is such a useful thing to be able to do, isn't it? I think looking at diagnostic questions and looking at the insights, actually covers so many elements of Rosenshine, also the Great Teaching Toolkit. So absolutely brilliant. Have you come across Guess the Misconception? They're great for, I think Craig Barton is a machine, isn't he? Churning out all these amazing things continually. And these Guessing the Misconception, I think, is very good idea for teacher professional development, really, and understanding misconceptions. Yeah, Dennis, I see use ED. I think a lot of people do. Spot the Mistake. Love Spot the Mistake resources because I think they can promote great discussion with students. And again, it's something that works well online because I can put the tools on and they can tick the mistakes or tick the correct or tick and cross. You're looking at, this is something that Craig Barton produced actually many years ago. And it's a tried and tested resource because the deputy editor was watching my lesson at the time, thought it was all very marvellous because it was the students were actually talking about it and talking about why the answers were wrong if they were wrong. So I think Spot the Mistake can be ever so useful. And there we are, back to one of my favourite TES authors again, Clumsy Clive, on he does make a lot of mistakes, Clive. In fact, I know whether you keep up with Andy, but he's got a whole family of people making all sorts of mistakes now and not showing enough working and all sorts. But right, Spot I have got, and I'll make sure I put a link to it. Andy Lutwich has got a whole series of Spot the Mistake on TES resources. Now, if you Google, just go to TES resources, find Andy Lutwich's shop, and then search Clumsy Clive, and you will see the whole lot. Right, but what I'll do is I'll make sure that my Spot the Mistake blog post, where I've got lots of Spot the Mistake resources, is available on the website. And we've got Clumsy Clive GCSE, and we've got Erica, who makes a lot of errors at A-level. So again, highly recommended. I think Andy's seen all the misconceptions that we've all seen, and true to form, the wonderful man has actually put all the answers in and said what the mistake was. But again, this I find promotes fantastic discussion with students. So yeah, there's more. There's lots. Another source, Algebra by Example. Very, very nice, because look at this. We get a really nice clear diagram. This is all free as well. And questions and prompts, all really good for class discussion. So, and again, there's a whole set of algebra resources that you can download. What I'll do is probably certainly by tomorrow morning, I'll just make sure that everything I've mentioned is clearly available. I think it is. I will just run through. Right, and there's more. Yes, look. So, what did Terence do wrong? So you're presented with work. There's questions, and the nice thing is then it's my turn, your turn. Bit of discussion, and then the students can have a go themselves. So just a fantastic source of examples. Right, let's skip on a little bit. I've also included some research in 100 words. I think really nice, because we haven't got time to read great long papers, have we? So sometimes these extracts, just the good points, so useful. So Chris Moyes has done this lovely series of sort of research in 100 words. So recommend that. A quick read of all the important points. Right, just briefly now, just to finish, what do you use for reviewing things? Daily review, weekly, monthly review, reteach material when necessary. So it's something we do all the time, isn't it? And I think we do it naturally as maths teachers, because obviously you're thinking about the small steps, and before you teach something new, it makes sense to review the prior knowledge that they need. But there we are. This is me at the beginning of my algebra webinar recently, just while I was waiting, while the students were coming in, I always have something up, while you wait, and I just wanted them to write statements using algebra. So just a sort of, because we were going on then to look at notation and all sorts, and I knew that I needed this. Yeah, last term, last year, such a good idea from Dennis there. You can do that, can't you, on Matt Woodfine's maths whiteboard? So we're very fortunate, I think, as maths teachers, to have a great generosity amongst maths teachers sharing their resources. Now that's just my thoughts. We use review retrieval as a regular part of lessons, including sort of odd moments. And I've been known to, at the end of a lesson, you got sort of just a few minutes before the bell, so I let them pack up, but then I would be asking questions that they keep getting, kept getting wrong, like, solve x squared equals 16, and they forget it's got two solutions. But I'd be doing the sort of the chancing the answers back. But yeah, retrieval anytime at all. Oops, what that's doing there again. And there we are. I'm going to finish with that. Two things. No quiz retrieval strategy. So can I ask you, I hope you have learnt a couple of things today. Are there some takeaways for you? Is there anything you'd like to learn more about? You see the idea, but that's come from, there's a brilliant website, the retrieval practice website. In fact, there's I've got more. You can look at these later, but where are we? I just wanted to show you. Have you seen? See, there's more you can look at later. I just got some nice sites, but where's it gone? There we are. That's what I wanted to show you. Retrievalpractice.org. These are all free. Some very nice books there. You've got Interleave Maths Practice, How to Use Retrieval Practice, Spaced Retrieval Practice. So these are very nice. Oh, right, good. What a good question, Luna. Yes, I'm very careful with, especially webinars, depending on if I know that the screen sharing is very good and it's flawless, and I'm sure everything's going to work, then I might just have swap to sharing a screen and actually demonstrating something live. Sometimes, if I'm not sure that things are going to work very well, I do loads and loads of slides. I would kind of demonstrate how something works with just a series of slides. So, yeah. Yes. Oh, practice. You can never have enough practice, can you, Annie? I mean, that says it all. And I think successful students practice. You can practice on Seneca, can't you, Amelia?
Absolutely, you can. I have to say, Colleen, I'm absolutely blown away. That was such a wealth of resources. Thank you so much for sharing all of those insights. And for everyone who's watching as well, we'll send out the link to your amazing blog, which has got all of them on there as well, so that they can check out all of them in the meantime. I'll keep popping some more. We've got some more questions coming through, so please do send over all the questions you've got, everyone, while we've got Colleen with us. So we've got one here about favorite technique to check understanding.
Yeah, I think, thinking particularly of my distance learning students, very well chosen multiple choice questions, but also then discussion around it. But sometimes I will just put up a very simple question and then invite comments in the chat, and we'll have a conversation about it. I have a group of A-level students that we have regular distance learners, but they're doing this structured course, and we have regular webinars. So I find the multiple choice questions really, really useful. So are there any more questions? I think we've got some dodgy.
Yeah, working on blocking that.
Yes.
In the meantime, I had a question, Colleen, which I know you said you could do a whole webinar on it, but I'd be really intrigued to know kind of how, if you could expand a little bit on your use of colour in explanations and how that works for you.
Yeah, sure. I mean, I think it's used for emphasis. And what I can do actually as well, I mean, it'll probably be tomorrow I'll finish all this, but on the right hand side of my blog, then I can include, I've got a presentation on colour in mathematics, which has got lots and lots of examples. So it may be, I mean, for example, do you remember I showed the net of the cube and I was colouring the faces so you could see the clear relationship between the net and the actual cube? Algebra, the equating coefficients example I used. And my journey into colour started decades ago with some year 7 students. I think they weren't even called year 7 then. They were called year 7. Anyway, it was I've realised that they didn't appreciate that the sign belonged only to the term following it. So I started colouring the sign and the term. So yes, and also then for factorisation, things like that. Pick out the common factors in colour, and then the coloured bits come out and the black bits are left inside. If I put the link up, you will see many examples. Or I might underline something in a GCSE question, underline parts of the question in a different colour and show where that's used in the solution. So yeah.
Oh, super. Yeah, that's fascinating. Thank you.
Yeah,
We got, looks like there's a couple more in the chat as well. We've got Dennis asked about diagnostic questions, multi-choice.
Oh yes. Well, that's I think that is that's just such a good tool, isn't it? For actually, if you discuss questions, diagnostic questions with students, and not only discuss the right answer, but why are the wrong ones? Why are they wrong? And I think I mentioned, didn't I, earlier, that setting a homework sometimes to write just, I don't know, 3 or 4 diagnostic questions, but the students have to do a write-up of why they chose the 4 options that they did. And then back in class, they had to try their diagnostic questions like on their friend. And again, you just get fantastic discussions, I think, with clever use of multiple choice questions. There's some loads of amazing multiple choice questions around. When I started teaching A-level, Edexcel, who weren't even called Edexcel then, what was it, ULIAC or something? University of London examinations, something or other, in the days when there were zillions of exam boards. But they had a most amazing multiple choice papers. I've still got them on a shelf somewhere. You can get them in the Emporium, but it's some very clever questions there. Must have taken a lot of effort. Yeah.
And we've got another one with an interesting one actually. How do you deal with students that have a hard time speaking up in class?
I think that's all about regular conversations and encouraging. With year 7s, when they're new to me, I say, asking questions is such a good thing, because then I know that you're trying, and then suddenly all these little hands are going up. But yeah, very much conversation. I think, now, who was it? W.W. Sawyer has a wonderful quote about students often, they don't say things wrong, they just express it very, very badly. Yeah, and I think, was it Dan Mayer? He said there's no such thing as mistakes and misconceptions. There's takes and conceptions, and I love that. Just valuing everything that they say and turning it into a conversation. I think, yeah, it's just so important. It's making your classroom a comfortable place to be, where it's just okay to be stuck. And in fact, it's good to be stuck, because it's when you're stuck that you learn.
I think that's a really lovely take on it. I love takes and conceptions. I think that's fantastic.
Isn't it? I know.
So I think looks like that's most of the questions from the chat. There's still a little bit of time, so if anyone wants to put any in there, please do feel free to. Lots of people saying that your blog is absolutely full of info, Colleen, which is true, and asking for the slides. So we'll see if you're happy for us to, Colleen. We can send those out afterwards.
Right.
Yeah, perfect. Oh, we've got one from Vishnupriyan as well.
So, checking, learn, and understand. Oh, factorization, linear equations. Yes. I mean, I think now here I'm going to start my Good Mathematicians Go Backwards presentation almost, because I don't know why we teach things separately sometimes, but I think sort of here's the answer. What's the question can be so valuable. So if you actually multiply out lots of brackets first, and then say, well, don't even tell them what factorization is, but say, okay, so we've multiplied out all these brackets. If the answer is this, what was the brackets? And actually just get them to go backwards without even telling them that what they're doing is factorization. So just linking, sort of backwards and forwards. I'll put and in fact, I've got some factorization examples in the, so probably tomorrow morning, I'll make sure that everything's complete, because I've strayed in to talk about other areas, but I have got there's a Good Mathematicians Go Backwards presentation. There's also, I've got stuff about factorizing. Actually, there's some good stuff about factorizing linear quadratics as well. Yes, Maths Week England. It's Maths Week England this week.
Super. Brilliant. Well, on that note, I think I'd like to say a huge thank you, firstly, obviously, to yourself, Colleen. That was absolutely amazing. I'm going to be dreaming about maths resources, I think, because of all of the amazing stuff that you've shared with us. And again, to everyone, thank you so much for joining us. I've just shared a link to Maths Week England. We're really excited to be a part of it. Go and check out what other amazing stuff they've got on, because it's a really cool program. I've also popped in the link to tomorrow's webinar, because we've got another webinar, so you can get tickets there. And then finally, I'm going to put in the form to fill out to get your certificate for attending today. And lastly, but certainly not least, I'm going to pop in the link to Colleen's blog as well. And you'll also get all of this information by email, everyone. So I'll send those across to you. And it looks like some people are filtering away, Colleen, there's a last question from Dennis about function machines, linear graphs and linear sequences taught differently when they're the same thing. So yeah, very much along the same thing.
I agree. Teach them together. Yes, I do. I do think we sometimes. I've often said, even in year 7, sometimes I've told them hints of things to come. So I said, right, you'll be studying this in year 9. When you get there, remember what we did, in year 7. But yes, absolutely. I think it's very artificial. Some of the things are taught in some years, because the younger ones are capable of much. Yeah, absolutely. Links wherever we can.
Absolutely. Brilliant. Well, in that case, I think we should say good night to everyone, and I hope everyone enjoys their nice evening, and have a lovely rest of your week.
Okay, great. Goodbye, and thank you.
Thanks so much, everyone. Bye.